In Helsinki, energy production is based on cogeneration. Cogeneration is a sustainable basis for eco-efficient innovations that meet the city's growing energy needs. The smart city energy system in Helsinki is centered around the Katrivala heating and cooling plant. The plant is the heart of the combined heating and cooling. It gathers and refines energy flows from buildings and distributes them back into circulation for use by the residents. In terms of its production capacity, Katrivala is the world's largest heating and cooling plant, producing district heat and cooling. Completed in 2006, the Katrivala plant is located underneath the Katrivala Park in Sornainen, where it connects to the rest of the underground infrastructure. Under the plant, there's a tunnel for purified sewage water and an intersection of multi-utility tunnels. The plant is close to the power plant area, the sea, and the customers. Katrivala plant has 5 heat pumps, a sewage water pumping station, a district cooling and district heating pumping station, and sewage water heat exchangers. Space has also been reserved for a 6th heat pump at the plant. The sewage water pumping station pumps purified sewage water from the tunnel into the Katrivala plant. The water comes from the Viki wastewater treatment plant. At Katrivala, the water is directed through filters into the sewage water heat exchangers. Depending on the time of year, the water comes to the plant at a temperature of 10 to 20 degrees, and its flow rate is about 260,000 cubic meters per 24 hours. This corresponds to the volume of 2.5 parliament houses. The heat of the purified sewage water is utilized in the sewage water heat exchangers. Cooled sewage water is directed to the open sea through the discharge tunnel, and the recovered heat goes to the heat pumps. The temperature of the return water from the district cooling coming back to the Katrivala plant is between 16 and 18 degrees. This return water is pumped by the district cooling pumps to the heat pumps, where the water is cooled again to about 4 degrees. The temperature of the return water coming back to the Katrivala plant is about 45 degrees. This return water is pumped by the district heating pumps to the heat pumps, where the water is reheated to about 88 degrees. The 5 heat pumps of the plant refine the waste energy into district heat and district cooling in a single process. The reason why the system is so efficient is that the pumps produce heat and cooling simultaneously. The plant meets the increasing demand for district cooling at the same time as it produces district heat. The key parts of a heat pump are the condenser and the evaporator. The refrigerant circulating in the heat pump transfers energy alternately to the supply water of district heat and district cooling. In the condenser, the refrigerant releases the energy into the district heating return water and heats it to 88 degrees for the supply water for district heating. That way, the refrigerant condenses and returns to the evaporator. In the evaporator, it cools down the return water from the district cooling to about 4 degrees to be used as supply water in district cooling. The compressor raises the pressure of the steam, which then moves back to the condenser, continuing the same circulating process. In cold seasons, the plant produces district heat for the heating of homes and hot tap water using heat pumps and the waste heat of sewage water. District cooling is produced from cool seawater and with heat pumps. In warmer seasons, the Katrivala heating and cooling plant produces mainly district cooling and also some district heat for the supply of hot tap water. The plant also uses cooling to collect solar heat. The smart energy system at the Katrivala plant combines the energy flows of heating and cooling. Buildings are used as energy sources when they're warmed up by the sunlight in the summer. Cooling is used for recovering surplus solar energy from buildings to be processed further at the heat pump plant. The system produces plenty of solar energy for the use of residents in Helsinki. In order to produce a similar amount of energy with solar collectors, you would need as much space as 30 football fields. That kind of space is not easily available in a densely built urban structure. The district heat output of the Katrivala plant is 90 megawatts, and that of the district cooling is 60 megawatts. These amounts correspond to the heating needs of a small Finnish town and the cooling needs of 100 large commercial buildings. In the winter, the plant produces district cooling for the needs of the entire city center, whereas the heat supplies cover a large part of the heat needed in downtown Helsinki. In the summer, Katrivala and the Salmisaari power plant produce district cooling to the entire city center. The district heat production of Katrivala is sufficient to cover a wide area. Over 80% of the production in the Katrivala plant is based on energy sources that would otherwise be left unutilized. The recovery of purified sewage water and the heat of data centers has received international awards as a model example of eco-efficient utilization of municipal waste energy in urban conditions. Smart energy systems and innovative solutions are a key part of Helen's development program, which aims for a carbon-neutral Helsinki by the year 2050.